Good evening. We come to you tonight from one of the most spectacular places in the United States, Glacier National Park in northwest Montana. The park was created in 1910 to protect its scenic splendors and wildlife. But protecting the wonders here is becoming increasingly difficult. Scientists now estimate that if global warming continues at its present rate, the namesake glaciers will be gone in less than 30 years. And those scientists are racing to understand what these rapid changes mean for the park's unique ecosystems. Glacier National Park is a million-acre wonder tucked beneath the Canadian border. This impressive terrain has looked much the same as it does today for about the past 10,000 years. The habitats here range from sheer mountain cliff to stunning alpine meadow. One of the lowest elevations in the park, at 3,000 feet, is near Lake McDonald. But just a few miles away, the Rocky Mountains seem to reach up and touch the sky at over 10,000 feet. And clinging to the open rock faces of the mountains are the namesake glaciers. It's hard to imagine these massive and dramatic ice fields could disappear in just a generation.
What's happened in just the last few decades used to take hundreds or thousands of years to occur. So we are experiencing something unusual. After all, these glaciers have been here for 7,000 years, and they're about to wink out in the next 12 or 15 years.
So what do we got across here?
Well, we have a cow moose and her calf.
Dr. Dan Faegre works for the U.S. Geological Society in Glacier National Park. The park has been his climate change laboratory for 18 years. What's the most important thing for us to know about glaciers and climate change?
Well, I think one thing is that the glaciers are clearly receding, and I think you can see this in a number of ways. Perhaps most compellingly is the repeat photography, where we take pictures that were taken, say, in 1900 or as late as 1887, and then we go to the exact same spot and take that picture again. So it's always a little bit of an adventure finding exactly where one of these photos was taken, 100 years ago. And in this case, we've got to get across this little swampy area. So, there we go.
In 1997, Faegre started searching the National Park Service archives and found old pictures, taken during the summer, of the park's glaciers. He then took those pictures into the field and found the same spot where the photo was originally taken and rephotographed the glaciers.
You can kind of see the glacier starting to come into view there.
We hiked with Faegre to one of those spots on a trail below Grinnell Glacier. Okay, so what's the significance of this spot? Why are we here?
Well, we finally found the spot where a photo was taken in 1887 of this glacier when it was obviously much larger at that time. And you can see simply from these three photos here that this vast field of ice here, where everything was all connected and went almost to the tops of the mountains, started getting thinner by 1920, but in particular, in the last 78 years here, it's completely disappeared. The lower part is completely gone, the upper part's separated, and you can see how thin it's become. And so what we'll do is we'll take another photograph of it today, and then we'll have one more for our collection, our series that shows, in a visually compelling way how these glaciers have disappeared.
Grinnell Glacier has receded so much since it was first photographed in 1887 that it has split into two smaller parts. Only a sliver of the original glacier, called the Salamander, is now visible from this repeat photography site. Faegre estimates that Grinnell is only 10% of its original size.
And of course, she set up the camera.
Faegre and his staff have repeatedly photographed 19 glaciers over the past 11 years. All of them have shown some sign of melting.
It's a pretty effective way of doing it. So I'll take a few photos here.
And it is not just the glaciers here. Scientists around the globe are using repeat photography to show the rapid decline of the world's glaciers. This is a melting glacier in Alaska. This glacier, in Peru, is almost completely gone. And this photo shows a glacier near Mount Everest that has melted into a large lake. Faegre says, although it may seem like a fairly low-tech approach to complicated science, repeat photography is an incredibly accurate way to measure the effects of climate change.
What they clearly show is that we're seeing a vast change in the glaciers of Glacier National Park. Many of these glaciers are now less than a fourth of the size that they used to be. In fact, when the park was founded, we had about 150 glaciers, and now we only have 25. So the vast majority of them have melted in the last century.
The glaciers were much larger when the first tourists came by railroad to this dramatic and remote corner of the new American nation at the end of the 1800s. The railroad companies built the first lodges and chalets in the park, and most were accessible only by hiking trails or horse. In 1910, as the number of visitors continued to climb, President Taft signed a bill making Glacier the 10th national park, and shortly afterward, work began on a much-needed interior park road. This is Logan Pass, named after the park's first superintendent, and this is the famous Going to the Sun Road that crosses the windy Continental Divide. The road stretches for 50 miles across the center of the park. It's a National Historical Monument, still considered to be an engineering marvel, just as it was when it first opened to the public in 1933. Today, more than 2 million visitors a year travel the dramatic Going to the Sun Road to see the famous namesake glaciers. The glaciers are geological phenomenon that formed when more winter snow fell in the high mountains than melted in the summer. Over time, the bottom layers of these snow masses turned to ice. As the ice thawed and froze through the seasons, it would shift and grind away at the rock underneath, shaping the deep, picturesque valleys of the park. These giant masses of shifting ice and packed snow have to be at least 25 acres and 100 feet thick to be considered a glacier.
So the transmitter is on?
Yeah, plugged in.
Okay.
In addition to photographing the glaciers, Faegre and a team of scientists and students spend weeks every summer on the glaciers, taking precise measurements with a GPS system. They use radar to calculate the depth of the glacier and the snow on the glacier.
The reason we want to get the thickness of the ice is so that we can calculate the volume of ice that's currently in the glacier, and then we can also calculate volume of ice that's gone away.
A weather station measures snowfall and temperature changes. The goal is to determine how much and how fast the glaciers are receding and how much water the glaciers still hold. Each summer, glacial melt sends millions of gallons of fresh water down the mountainside. Ecologist Dan Faegre says this water is vital.
50% of the water that humans consume on this planet comes from mountain regions, and here in the American West that figure is even higher. It's 85%. As a glacier disappears, it means that usually the snowpacks are disappearing as well, and because snowpacks act as sort of our reservoir system, we're basically losing our reservoir system. The snowpack has been declining for about 50 years, so we have less and less every winter, and it melts up to a month earlier in the spring. And so by midsummer, when we used to still have some snow around, most years the snowpack is depleted.
Faegre says the combination of an earlier thaw, less runoff, and higher temperatures have made forest fires an increasing problem. 100 years ago, there were an average 5 summer days above 90 degrees in Glacier Park. Now there are 20. And in 2003, there were a record 31 days when the mercury topped 90. Not coincidentally, 145,000 acres burned in the park in 2003. While fires are part of the natural cycle in the park, more intense and frequent fires make it difficult for burned areas to recover before being threatened again.
When you transform, as we did one year, up to 10 or 13%, I think it was that year, of the entire western part of the park with forest fire, you have then animal populations that are responding to that. And so you wind up with a different mix of wildlife, of different kinds of habitats like the forest versus the open areas. And so you have a cascade of effects.